So here's a question for you. What happens when the tools we built to make us more productive start turning against us? This week, we've got the first actively exploited Chrome 0 day of 2026. And if you haven't updated your browser yet, you're going to want to pause and go do that in a minute. We've got a CVSS 9.9 vulnerability in Microsoft's AI development SDK. And that's about as close to a perfect 10 as it gets. An AI coding assistant got its NPM packages hijacked, silently installing autonomous AI agents on thousands of developer machines. Youch. The first Android malware ever discovered that uses Google's own Gemini AI in real time to stay alive on your phone. And to cap it all off, a Russian speaking threat actor used commercial AI tools to breach over 600, yeah, that's 600 firewalls across 55 countries in 5 weeks. There's a theme here, and it's impossible to ignore. AI is reshaping both sides of the cybersecurity battlefield and fast. Let's get into it.
Forge OS is online and operational. Welcome, operator.
Hey guys, I'm your host Cypher Saval, and welcome to Exploit Brokers by Forgebound Research. This is HN episode 63 or HN63. If you're watching on YouTube, do me a favor, hit that like button, subscribe if you haven't already, and ring the bell so you don't miss an episode. If you're listening on your favorite podcast platform, a follow and a 5-star review go a long way in helping other people find the show. And honestly, it means a lot. As always, I'm sharing information and awareness here. I'm a software engineer with a background in cybersecurity, but I'm not your security consultant. So talk to your own security team for anything specific to your environment. But all right, we've got 5 stories today that are stacked. Let's jump in. All righty. We are starting with something that hits close to home for literally everyone listening to this. Google Chrome, the browser that statistically most of you are probably using right now, just had its first actively exploited 0 day of 2026 patched. At least there's some good news there. For folks who might be newer to the show, a 0 day means attackers were exploiting this vulnerability before a fix even existed. It's the worst case scenario in vulnerability disclosure. The window between discovery and exploitation in this case was essentially zero. The vulnerability is tracked as CVE 2026 2441, and it carries a CVSS score of 8.8 out of 10. That's a pretty high severity. It was reported to Google, and Google had a patch out by February 13th. That's a 2 day turnaround, folks. That's credit where credit is due. That's quick. Now, here's the thing, attackers were already using it before the patch dropped. So, what is this vulnerability technically? Well, it's what's called a use after free bug in Chrome's CSS engine. I know, CSS, specifically in the CSS font feature values map implementation. To give more context, use after free is a type of memory corruption where the program frees a chunk of memory but then continues to reference it. Think of it like checking out of a hotel room, but the front desk keeps sending people to your old room. Except in this case, the attacker gets to decide what's in that room when the program comes back looking. So the root cause here is an iterator invalidation bug. Chrome was looping over a set of font feature values while simultaneously modifying the same set. That left the iterator pointing at stale freed memory. And an attacker who crafts the right HTML page can control what gets placed in that memory, leading to arbitrary code execution inside Chrome's sandbox. Ouch. Now, the sandbox is important. Code execution inside the sandbox is bad, but it's not full system compromising by itself. An attacker would need a second vulnerability, an escape of the sandbox escape, to get full control of the system. But chained exploits are not unusual, especially in targeted attacks. Google, as is standard, has been tight lipped about who's being targeted and how widespread the exploitation is. All that said is that an exploit for CVE 2026 2441 exists in the wild. The patch versions are 145.0.7632.75 and 76 for Windows and Mac, and 144.0.7559.75 for Linux. And this doesn't just affect Chrome, it affects every Chromium based browser. For those who are also not aware, a lot of browsers are based on Chromium, including Google's Chrome. Chromium is the base. So if you're on Microsoft Edge, Brave, Opera, Vivaldi, keep an eye out for those updates because they will affect you as well. Now, it's worth knowing this is Chrome's first 0 day of 2026, but it won't last. Google patched 8 of them in 2025. So here's what I would personally do: I have Chrome set to auto update, in my case, Brave, but I also manually check periodically because if you never close your browser, those updates can sit there waiting. Three-dot menu, help, and then about. Takes about 10 seconds. Update your stuff. Okay, the next story, getting a little bit more specific now. So, the browser vulnerability that affected everyone, that's going to hit particularly close to home for my developers out there. And this one's a pretty big deal. So, Microsoft's Semantic Kernel Python SDK, which, to give context, is one of Microsoft's key frameworks for building AI powered applications, has a critical remote code execution vulnerability. We are talking about CVE 2026 26030 with a CVSS score of, drumroll please, 9.9 out of 10. Man, that's golden goose of hacking right there. That's upper level red flags when you see it. But what's actually happening here? Well, the vulnerability lives in the in memory vector store filter functionality. If you're building AI applications with semantic kernel, things like RAG, which is retrieval augmented generation, AI agents, semantic search systems, you might be using the in memory vector store to store and query vector embeddings. The problem is a classic code injection flaw. Even though we're talking about AI, there's a lot of stuff that, I mean, AI is code. CWE 94, improper control of generation of code. The filter mechanism doesn't properly sanitize input, meaning an authenticated attacker can inject and execute arbitrary code through the filter parameters. We're talking about network accessible exploitation with low attack complexity, low privilege required, and zero user interaction needed. That's pretty bad. And it's a pretty bad attack vector at that. So, an attacker doesn't need to trick anyone into clicking anything. They just need authenticated access to the application. And if that application is exposed to the network, which many AI services are, the attack surface is pretty significant. So you're not just compromising the semantic kernel instance, you could definitely be pivoting to the broader infrastructure. Microsoft has patched this in version Python 1.39.4 of the semantic kernel SDK. If you're running anything earlier than that, this is something you're going to want to look into. So, something to keep in mind: this is a critical vulnerability in an AI development framework, which means the targets are developers and the AI applications they're building. So, if you're building with semantic kernel, update to 1.39.4 or higher. And as a workaround, the general guidance for Microsoft is to avoid using the in memory vector store in production scenarios until you've patched. A patch does you no good if it's not installed, and you got to update your libraries and update your other stuff because if they're not updated, there could definitely be vulnerabilities in that. And as we are speaking of AI developer tools being a target, our next story is something else. Because this isn't just a vulnerability, this is an active supply chain attack on one of the most popular AI coding assistants in the developer ecosystem. Cline, if you're not familiar, is an open source AI powered coding assistant. It's got over 5 million users. It integrates with VS Code, JetBrains, and has a CLI or command line interface tool available on NPM. On February 17th, 2026, someone compromised Cline's NPM publish token and pushed a malicious update, Cline version 2.3.0, that silently installed OpenClaw on every developer machine that pulled the update. So, for context, OpenClaw, formerly known as Moltbot and formerly known as Claudebot, is a self-hosted autonomous AI agent platform. I'm pretty sure you've been hearing about, AIs having their own version of Reddit and all that jazz. This is kind of going into that world. So, it's been incredibly popular recently, but it's not inherently malicious, but it has broad system permissions. We're talking full disk access. It runs as a persistent background daemon via WebSocket. If an attacker silently installs it on your machine without your knowledge, well, that's a persistent foothold with enormous potential for recon, data exfiltration, and further compromise. The definition of the AI agent and how it's set up, it gets so much access. There's already been horror stories of people willingly installing the agents and it already wreaking havoc on their stuff. Imagine not even knowing it's installed. That's just going to get that much more interesting. Here's where the technical chain gets really interesting, though, and honestly, pretty scary. This attack started with a vulnerability that security researcher Adnan Khan discovered and responsibly disclosed. He found that Cline's automated GitHub issue triage workflow, which used an AI model to process incoming issues, was vulnerable to indirect prompt injection. So let's break that down for a second. When someone opens a GitHub issue on Cline's repository, an AI model triages it. Khan discovered that a carefully crafted issue title could manipulate the AI triage bot into executing arbitrary actions within the CI/CD, or continuous integration, continuous development pipeline. From there, the attack chain used GitHub Action cache poisoning to pivot from the low privilege triage workflow to the release pipeline, ultimately leaking NPM publication credentials. So, Khan reported this responsibly. Cline patched the prompt injection vulnerability within 30 minutes of the disclosure on February 9th. That is a quick turnaround. But Oh, and they also rotated the credentials. But, and this is the kicker, they rotated the wrong token. The NPM published token that was actually exposed remained active. 8 days later, on February 17th, an unknown actor used that still valid token to publish the compromised package. The tainted or the poisoned version was live for approximately 8 hours from 3:26 a.m. to 11:30 a.m. Pacific time, according to Step Security. It was downloaded roughly 4,000 times. Think about that. 4,000 installs of OpenClaw given to a malicious actor. Cline has since released version 2.4.0, deprecated 2.3.0, revoked the compromise token, and moved to OIDC based publishing via GitHub Actions. Now, I could totally see how the wrong token gets compromised here. If they're thinking, or if there's any kind of misunderstanding, and the token that they use for their development or the pre release, if that gets compromised, well, that's not the token that got leaked. So, but they're thinking, oh, this affected the development pipeline. Let's go ahead and get that done. Because nothing makes the release pipeline until it usually hits master or main, depending on which naming paradigm you're using. So the development pipeline, you could have just dozens and dozens of branches off that. There could be different development environments, different deploy environments for the development service, for staging service, so on and so forth. I don't know specifically how Klein had it set up, but this is probably why the wrong token happened. I don't know for sure. This is just a developer speaking because this is what I've seen as a developer. You have a lot of environments. Now, a few things to consider. First, if you've installed Cline, which is the command line interface, during that 8 hour window, you got to check your system from OpenClaw. Cline dash dash version will tell you what version you're on. If you're on 2.3.0, update and run npm uninstall -g OpenClaw. Second, this attack chain started with a GitHub issue title, a natural language prompt injection flowing through an AI triage bot through CI/CD to a published package affecting millions of users or millions of potential users. That's not theoretical anymore. That is an operational reality. Now, Klein had OIDC set up, but left the old tokens active. And that's the gap where the attacker walked through. And the other thing to consider is that when you have an automated system automatically accepting or doing things for you, if that system is not secure, it's like anything. When you own a server, if that server has high enough privileges, it's going to cause mayhem. So all the AI that's being deployed, all the agents that are being deployed, the bots that get deployed, they're all pieces of code. They're all software doing a thing. And if at any point they misbehave and an attacker gets control of them, then depending on how much access they've been giving, oh my goodness, that is where things escalate quickly. And that's just what we're seeing more and more of. AI is developing at such a quick speed that prompt injection and all these other attacks are still pretty hard to mitigate. And that's the part that's even scarier. It's not like normal code where once you have certain things, this section of code becomes harder. When you look at prompts and prompt injection, there are so many things that go into trying to prevent what's known as prompt jailbreaking. You heard a lot about certain chatbots, really widely used ones. There's tons of ways to do a jailbreak on it so that way you can get answers that it may not want to give you. But that's kind of the situation we find ourselves in. Okay. So we've been talking about AI tools being targeted by attackers. We've been talking about AI tools being used. But let's flip the script for a second. Because in this story, the malware itself is using AI to operate. If you remember one of the episodes that we did recently, which was last week's episode, if you haven't checked that one out, please go check out HN62. But we are now seeing, again, it's just evolving. The researchers at ESET have discovered what they're calling the first Android malware to use generative AI in its execution flow. We previously talked about a malware using the API to generate C sharp code. Now we're seeing Android malware use it. So it's called PromptSpy, and it uses Google's own Gemini AI model at runtime to help it stay alive on infected devices. That's not normal. That's like new territory, scary new territory. To give context on how this works, traditional Android malware relies on hard coded tab coordinates, UI selectors, and specific device dependent scripts to interact with the phone's interface. The problem for malware authors is that Android is incredibly fragmented. Different manufacturers, different OS versions, different UI layouts. What works on a Samsung Galaxy might not work on a Pixel or a Xiaomi. And for any of my Android developers, the same headache applies for pretty much any Android developer. It just, the Android ecosystem has so many more devices available to it than, say, the iOS ecosystem. Because while the iOS ecosystem has multiple devices, it has proportionately less. So you may have four different versions for this year, but then how many different Android versions get released? I mean, Pixel has like three or four, Samsung has three or four, Xiaomi has several. You're talking about dozens of devices versus like four new ones for iOS given the same year. So PromptSpy solves this problem by querying Gemini. Here's the flow. The malware takes an XML dump of the current screen, XML being the markup language, all the visible UI elements, their text labels, class types, and positions, and sends it to Gemini along with a predefined prompt. Gemini analyzes the screen and responds with JSON instructions telling the malware exactly where to tap and what gestures to perform. Well, here you send an image, you send this data to the AI, and the AI says, oh, you actually want to click 100, 100 for this device, but this device over here, you actually want it to be 150, 150. And that makes it so that you are creating malware that is much easier adaptable to different devices on the Android side. That's scary next gen stuff. So the malware executes the action through Android's accessibility services, captures the updated screen state, sends it back to Gemini, and the loop continues until Gemini confirms the task is complete. Well, what's it trying to do with the loop? Persistence. Specifically, it's trying to lock itself into the recent apps list. That's the multitask view, so it can't be swiped away or killed by the system. It persists across reboots this way. But the AI assisted persistence is just one piece. PromptSpy's primary purpose is to deploy a built in VNC module or virtual network computing and giving attackers full remote access to the device. It can capture your lock screen pin or password. It can record your unlock patterns as video. It can take screenshots on demand, and it abuses the accessibility services to place invisible overlays on top of uninstall buttons. So when you try to remove it and you're tapping on a transparent rectangle that does nothing. They're just preventing you from doing it using built-in systems that are actually meant to help people. The only way to get rid of it, reboot into safe mode where third-party apps are blocked and then uninstall it. And that is just a pain in itself. Now, ESET traced the samples to a distribution website impersonating JP Morgan Chase under the name Morgan ARG. This is likely targeting users in Argentina. They also observed Chinese language strings in the codebase, suggesting development ties to a Chinese speaking environment. They haven't attributed to any known threat group, though. Now, here's the important caveat. ESET says they haven't seen PromptSpy in their telemetry yet. It's possible that this is still at the proof of concept stage, but the fact that it was distributed via a dedicated domain and impersonated a major bank tells us that it's more than just some academic exercise. Even if this particular sample is limited, the technique is out there now. It is either being tested, trialed, or this is just the version of it that got caught. We'll see. So, some things to keep in mind. Ultimately, the biggest takeaway is that this isn't specific to malware. It's just a trend. Malware that can dynamically interpret any screen on any device using AI is a fundamental shift. Bad grammar used to be a reliable phishing indicator. AI changed that. Hard coded UI coordinates used to be a limitation for mobile malware. AI is removing those limitations one by one. Something to be very aware of going forward. Now, for Android users specifically, Google Play Protect does detect known versions of PromptSpy. The malware has never been on Google Play. This is a good reminder about side loading apps from unknown sources. One of the biggest proponents, or one of the biggest reasons a lot of people say, well, Android, is because you can technically install whatever you want without being locked down by the ecosystem. If you're side loading an app, you don't know where it came from, that could land you in a heap of trouble. Okay, but let's just say moving on. So, oh man, this is the capstone story, and it's interesting to say the least. It brings the AI theme full circle. We've been talking about AI developer tools being vulnerable. We've been talking about AI coding assistants being compromised. And we've been talking about malware using AI for persistence, among other things. Now, an entire attack campaign orchestrated with the help of commercial AI services is here. Amazon Threat Intelligence dropped a report revealing that a Russian speaking, financially motivated threat actor used multiple commercial generative AI tools to compromise over 600 FortiGate firewall devices across 55 countries in just 5 weeks. From January 11th to February 18th, 2026, at least at the time of me recording this. Here's what makes this story stand out. Amazon describes this threat actor as having limited technical capabilities. They overcame that limitation by using AI as what Amazon calls an AI powered assembly line for cybercrime. Cybercriminals are vibe coding, and it's terrifying. So, how did this actually work? It started with the basics: exposed management interfaces and weak creds. No 0 days, no sophisticated exploits. The attackers scanned for FortiGate management interfaces exposed to the internet across ports 443, 8443, 10443, and 4443. Then attempted authentication using commonly reused passwords with single factor authentication. Security by obscurity does not work. If your management interface is internet facing with weak creds and no MFA, it's not a matter of if, it's a matter of when you're going to get owned. Once inside, the attacker extracted full device configurations, SSL VPN credentials, firewall policies, network topology, you know how the network's set up, IPsec VPN settings. Then they fed that network topology data directly into the AI tools, which generated structured attack plans for lateral movement, domain compromise, and credential harvesting. And I know you're going to be like, well, we should put more guardrails on AI. Well, the problem is what I just mentioned earlier: you can do jailbreaks, and now you're just a cat chasing a mouse. Now, according to reporting from security researcher German Fernandez, the attacker used a custom system called Arxon that queried large language models, including DeepSeek and Claude, to generate attack plans. These plans included instructions for gaining domain admin, suggesting that locations to search for credentials, recommended exploitation steps, and lateral movement guidance. In some cases, Claude Code was reportedly configured to execute offensive tools autonomously. We are seeing tons of like MCP, ACP, and all this other stuff. Of course, there's going to be integrations with more tools. That's just the way we're seeing things. AI is being given access to anything and everything, and developers are finding really interesting ways of using it, but so are cybercriminals. Now, what was used on the autonomous tools: impact scripts, metasploit modules, hashcat, and without requiring the threat actor to approve each command. There is different ways where you can approach AI driven development, whether good or bad. And there's the fully hands-off autonomous approach. There's the approve every single thing that the AI wants to do, and then somewhere in the middle. Amazon discovered this campaign because the attacker had hilariously poor operational security. Their staging server at IP 212.11.64.250 was publicly accessible and hosted AI generated attack plans, victim configurations, and source code for custom tooling. The code itself showed telltale signs of AI generation: redundant comments, restating function names, naive JSON parsing, empty documentation stubs, and overformatted but architecturally simplistic code. The campaign was sector agnostic and spanned South Asia, Latin America, the Caribbean, West Africa, Northern Europe, and Southeast Asia. Post exploitation activities included DC sync attacks against the Active Directory, lateral movement via the pass the hash and pass the ticket, NTLM relay attacks, and targeting of VM backup and replication servers, which aligns with typical ransomware preparation, though no ransomware was actually deployed. Could this be a dry run or something else? Not sure at this moment. Now, something worth knowing, this is a story that should keep some security professionals up at night. Not because the techniques are new, but because the barrier to entry has collapsed and it's going to keep going lower and lower and lower. An unsophisticated attacker used off the shelf AI, breached 600 devices across 55 countries in 5 weeks. The AI generated their tools, wrote their attack plans, and in some cases executed the attacks autonomously. As Amazon CISO or CISO, CJ Moses put it, organizations need to anticipate that AI augmented threat activity will continue to grow from both skilled and unskilled adversaries. The defenses that matter here are fundamentals. Don't expose management interfaces to the internet. Enforce MFA everywhere. Use unique credentials for VPN access. Isolate backup infrastructure. And like always, update your stuff. And in this case, don't leave default configurations out. It's just a thing, change admin to something useful. Not saying they left it as admin, but if you're leaving something as admin, change it. Just an idea. All right. So let's just kind of do a recap and takeaways to wrap up the episode. So, the 5 stories this week, and honestly, it's a pretty clear theme that we're seeing here. So, the takeaways are: one, update your browsers. We've seen Chrome's first 0 day of 2026, and it's patched CVE 2026-2441. A crafted web page is all it takes. This applies to Chrome, Edge, Brave, and every Chromium based browser. Check your version and update. That one's easy. Next, AI development tooling is now a high value target. A CVSS 9.9 in Microsoft Semantic kernel, a supply chain attack on Cline. If you're building with AI tools, the security of those tools is now part of your threat model. And that's just the way we got to move forward. Next, supply chain security isn't about dependencies, it's also about your CI/CD pipeline. To reiterate, continuous integration, continuous development. The Cline attack started with a GitHub issue title that manipulated an AI triage bot. If you're using AI automation in your build pipelines, treat those AI agents as privileged actors that need governance. So, next, or at least the next point, AI is being weaponized on both sides of the equation. PromptSpy uses Gemini for malware persistence. The FortiGate campaign used AI to generate attack plans and execute tools. This is not theoretical, folks. It's operational. The threat landscape is evolving faster than we've seen before, and it ain't slowing down. Lastly, fundamentals still win. 600 firewalls breached, not with 0 days, but with weak passwords and exposed management interfaces. Use your MFA, do credential hygiene, network segmentation, and patching. They aren't glorious, but that's what stops the attacks before AI even enters the picture. AI just accelerates things. If you do things right, it should be harder. Now, above all, security is person plus tech. The best tools in the world do not help if you don't use them. Stay informed, stay aware, and honestly, stay curious about what's happening in this space. It's going to always be ever changing. So you got to have some curiosity. But that's going to do it for HN episode 63 or HN63. Thank you as always for spending your time with me. I know you've got a lot of options where you get cybersecurity info, and the fact that you chose to be here means the world to me. If you found value in the episode, if even one of these stories made you think, made you check something, just made you a little more aware, please share with someone who needs to hear it. A colleague, a friend, a family member. Cybersecurity isn't just an IT thing, it's an everybody thing, especially as we see things expanding faster and faster to everybody. We're all in this together, guys. This has been your host, Cypher Saval, and I'll catch you in the next one.